What's the slope of the purple line? 2. Good. If lines are parallel, then they have the same slope. So, since the blue one had a slope of 2, the purple one also has a slope of 2. That's a large portion of today's assignment right there. So, get out some notes. We're going to be starting 1.5. Yeah, just a second. Getting that home page. Oh. Trying to get to know everybody by 9. Hold on. Katie Beth, you want to pick up my DOMs for me, please? Miss James is going to come around and get your DOM, so please have it ready for her. One five. Oh. You know, I don't know. I never really look at that, but I would guess it'd be called equations of lines. If I was a guessing man. It's the same as in your book. If you open your book to 1.5, it would be right there. Oh, well, sorry. Also, if you have any work to turn in, please get that in. Beef nachos, fish and cheese sandwich, pinto beans. Ooh, whole kernel corn, not like the half kernel corn crap. Whole kernels. Sour cream and lettuce. Well, what do you want from me? I'm just reading the menu. Taco salad, breaded chicken with whole grain buns. So they're not like holding back the buns on you. All right. Here we go. Were there any questions on the DOM? Good. Write an equation of the line in point slope and slope intercept form. So they're going to provide you a blue line, but then for the purple one, you have to come up with the equation. They're going to give you the equation for the blue line. So what's the slope of the blue line? 2. Now, if lines are parallel, they have the same slope. What about perpendicular? That's right, negative, and you flip it. So this was 2 over 1, so now it's 1 over 2, because you flip it if it is perpendicular, which it is, and you change the sign. So that's your slope. Now what are we going to do? Give you a hint. They give you a point, and then they ask you for this. Yeah. Point slope form. Y minus the y value equals the slope, bless you, times x minus the x value. Boom! Point slope form. Done. What do we have to do for slope intercept? Solve for y. Y minus 4 equals negative 1/2 x plus 1. Negative 1/2 times negative 2. Add the 4. And there's your slope intercept form. And you have done both parts of the problem. You'll have one parallel and one perpendicular to do. So just remember those little slope thingies, and you're golden. Questions on that slide? Hey, man. I was worried. I really was worried. I was asking about you. I'm glad you're here. All right. Use the given conditions to write an equation for each line. Ooh, just the exact same thing. Point slope and slope intercept. So, Passing through that point and parallel to that line. So what do I need from this line, y'all? The -4 is the only thing I need. I need the slope. So point slope, y minus -10 equals the parallel slope, which is the same, times x minus -8. Boom, first part's done. Slope intercept, y plus 10 equals -4x minus 32. Subtract the 10. And boom, there's slope intercept form, and you're done. What's the slope going to be on number 7? Very good. Flip the fraction to 5/1, change the sign, and everything's going to be the same as number 5, except the slope will be -5 right there. And the point will be different. Any questions about something you see on the board? Use the given conditions, so basically the same exact thing. Oh, and general form. Not slope intercept, but general form, which we'll get to in a second. Well, actually, this is general form. Now, here are the restrictions for general form real quick. It's going to be ax plus by plus c, where a, b, and c are just numbers. The only restrictions are that a, b, and c are all whole numbers. You can't have any fractions or decimals. This is going to be simple because by setting it equal to 0, you can multiply both things by whatever you want. So, for instance, this is just a what-if scenario. If we were to get something like 1/4 x minus 1/3 y plus 2 equals 0, well, you can't have fractions, but because the other side's equal to 0, it's quite simple to just multiply everything by like one big thing and get rid of all your fractions. What do both 4 and 3 go into? 12. You can just multiply both sides by 12 and get 3x minus 4y plus 24 equals 0. Boom, you've gotten rid of them. And that's perfectly legal. Because all you've done is inflate your problem. You haven't changed it at all. So that's how we're going to do that. Also, the a value has to be positive. They're really picky about their general form. So if this was negative, you could just multiply everything through by -1. It doesn't matter if it changes everything else. Weird. So let's actually do the problem. Passing through that point and parallel to this line. Now, there are two ways you could find that slope. One, you could just solve for y and pull it out, but there's also a formula. If you have a line in general form, the slope, let me see if I can remember this correctly, should just be -b over 2a. It's your slope formula. No, -b over a. That's what it is. -b over a. If you're in standard form, -b over a. Now, that would make this one positive 3/2. Now, to show you how that works, just for this first one, I'm going to solve it for y and show you that we could just pull it out, but you're going to get the same thing. So if I were to solve this thing for y, that'd be 3y, if I added it to the other side, equals 2x minus 7. Ooh, I might have had that wrong. It might be a over b. Over 3 when you divide. Yep, my bad. It is a over b. You might want to change that. And I don't know why I left this negative on here. In fact, that whole thing's just wrong. A over b. You're not going to use general form, but like 2 or 3 times all semester. And they're picky. My bad. It's just a over b. So when you have general form, just a over b. So in this case, that would have been, no, it was negative. Dang it, I was right in the first place. Leave the negative there. I'm telling you, I never use general form. So 2/3, which was just 2 over the negative of that. Negative a over b if you just want to pull it out. So let's just do that step on number 11. What's the slope going to be of this line? Well, let's not worry about the perpendicular just yet. What's the slope of this one going to be? Yeah, it would have been positive 1 over -2, but with the negative, it's going to be positive 1 over positive 2. Simply negative a over b. Now, perpendicular to this is going to give you a slope of what? Very good, -2. Flip that, change the sign, hence perpendicular. Now, from there, you're just going to do point slope form. Y minus -7. I don't know why I just chose to do number 11. equals the slope times x minus its x-coordinate. There is your point slope form. For standard form, just put everything on one side. So you've got y plus 7 equals negative 2x plus 8. Well, you know you need the number being multiplied by the x to be positive, so I would just let that dictate which one you move to which side. So let's move this stuff over, and that's going to be positive 2x plus y plus 15. And there's your general form. Yes, it would. Positive 7 minus 8. Well, this has been like the worst slide ever. Botched this 18 times. Good thing you guys are here. 2x plus y minus 1, and there's your general form. Feeling a strong desire to go ahead and work number 9 since I botched the first parts of the slide so bad. Really need a salvation piece here. So my slope is 2/3, and here's my point. Y minus my y value equals, now it was 2/3, but we're parallel, so it's still going to be 2/3. X minus my x value. So there's point slope. So that'll be y minus 2 equals 2/3 x plus 4/3. When you multiply this by both of those. It's already positive, so I'm going to move this stuff over here. So that'll be 2/3 x, if I got any more room, minus y. What's 4/3 plus 2? That's 4/3. How many thirds is 2? How many thirds is just 2? 6. So 4/3 plus 6/3 is 10/3. Now, what's the problem with this right now? Fractions. Can't have fractions. So we're going to multiply everything by what common denominator? 3. Giving us 2x minus 3y plus 10 equals 0. And here's your general form. Sorry about the first part so bad, but negative a over b will get you your slope in general form. Questions? Find the average rate of change. Average rate of change is just slope. The only difference is this a line? No. Of course, we haven't gotten into what that is specifically yet, but that's going to be some kind of parabola, which means its slope is ever changing. So all we can do at this point in the year is find at any given point what will our slope be at that point. So let's do number 15. Let me take it elsewhere. We're just asked to find the average rate of change. Now normally, slope formula, y2 minus y1 equals x2 minus x1, and all is fine in the world. However, this looks like this. That's what our graph looks like. But they say between x equals 3 and x equals 5, what's the slope of that? If you were to draw a secant line through those 2 points, what would the slope of that line be? Well, what are the x values of that line? 5 and 3. It's going to be the exact same slope formula. But in your book, instead of just saying y2 minus y1, they stayed in function form. Because how are we going to find the y values of this function at those points? Plug them in, exactly. If you plug 5 into the function, you'll get its corresponding y value of its coordinate. So 5 squared is 25, plus 10, was that 35? So 35, y2 minus y1 over x2 minus x1, just like yesterday's DOM. Then you plug 3 into the function. 9 plus 6, was that 15? 15. So 20 over 2 gives you an average rate of change of 10. Now, rate of change is always like something per something, but for the time being, you can just give me a number. In your book, if you actually look at the formula for this, it'll either say f of x2 minus f of x1 over x2 minus x1, Or the more universal way, you'll see it here, calculus, calc 2, however how you go, will just be delta y over delta x, which just means the difference in your y values divided by the difference in your x values. They use delta for that. I don't know why. Are there any questions about where we got these numbers? Because if you can get those numbers, then you can do the problem. Good question. You get where I got the 5 and the 3? Good. They'll always provide you with those. Well, if I were to just say, here's an x value, here's a function, what's its y value, what would you do? You'd plug it in. Well, if I didn't show you the graph, I gave you a function like this. And I said, here's some x values. What's the y value for this x value? You'd have to plug it in. That's all we did. We plugged in 5 to that function and got 35. We plugged 3 into that function and got 15. And therefore, that way, see what that did was, that basically generated these coordinates. 3, 15, and 5, 35. And then we just took the slope of those coordinates. Questions? Absolutely we can. In fact, we can do 4 more. Yes. Rate of change is like transitioning you from thinking slope into thinking velocity, because you're getting into the more calculus and physics portion. So that's like a segue, rate of change. Suppose the ball, see, physics, calculus. Suppose that a ball is rolling down a ramp. The distance traveled by the ball is given by the function in each exercise. So here's our function this time. Where t is the time in seconds after the ball is released, and s of t is measured in feet. For each function, find the ball's average velocity from, and then they give you 2 different time intervals. So, now, why do you think that the ball would be a different speed at one point and another point? Yeah, acceleration. When you, I'm going to take this thing off. It's really annoying. Okay. Yeah, when you throw something up or roll something down a hill or blah, 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 unless it's a perfectly smooth surface and flat, it's going to either accelerate or decelerate, which is why you have to continually find its difference change in speed. So here we go. We're going to do the exact same thing for this problem that we did on the previous problem. So what goes in my denominator? Let's do part A. It doesn't matter which order you put them in. I just always put the second one first. Where am I going to get my x values? Plugging them in. Marco, what would I do without you? 4 squared times 10 is 160. 3 squared times 10 is 90. 70 over 1 gives you an average rate of change of 70. Now, let's see. We were going in feet per second. Feet per second. Part B is the exact same thing, except instead of those numbers, it's going to be 3.01 minus 3 on the bottom, and on the top, yikes, I need somebody with a calculator to punch in 3.01 squared and times it by 10. No, that's wrong. 9.06 times 10. 90.6, and this is just 90. So, 0.6 over 0.01, somebody with a calculator. Although I should probably just be able to do this. Fine. Shun, 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 shun. So it'd be 60? Yeah. Thank you, math teacher. 60 feet per second. Well, that says F per S. Let's go with it. Questions about where any of those numbers came from? Sorry, this really does say feet per second. I know it's blurry. Questions? I'll leave that up there for a moment because I know this is probably going to be potentially confusing on your homework if you don't have the example in front of you. Does anybody need me to leave this up there any longer? Okay, last slide. Write an equation and slope-intercept. So this is basically the same thing we were doing, just a little bit more outside the box thinking. Slope-intercept form. Ooh, just slope-intercept form. That's nice. It is awesome. So we need the y equals mx plus b form of these three scenarios. The graph of f passes through the point -1, 5, so I'm thinking point slope, and is perpendicular to the line whose equation is x equals 6. What is the slope of the line x equals 6? Not quite. What is the slope of the line? What does the line x equals 6 look like? Somebody show me with your arm. Very good. It's vertical. What's the slope of that line? Undefined. Now, what's perpendicular to a line that's vertical? Horizontal. Now, what's the slope of that line? 0. So, you have point slope. Y minus your y value equals the slope, which is perpendicular to vertical, which is 0, times x minus your x value. Well, what's 0 times anything? 0. So you're just left with y minus 5 equals 0, which y equals 5 would be the slope-intercept form of that. So these are like outside the box thinking questions, but they're the same exact problem that we were doing a few slides ago. All three of these are going to kind of make you think like that. 23, the graph of f passes through that point and is perpendicular to the line that has an x-intercept of 2 and a y-intercept of 4. What do we do? How can... We're actually going to use both of the intercepts to find... Was that you, Justin? Good job. We're actually going to use both the intercepts to find the slope, because this is the point 2, 0. This is the point 0, -4. So finding the slope, -4 minus 0 over 0 minus 2. Remember slope formula? -4 over -2 gives us a slope of 2. But we want the perpendicular slope to that, which is going to be... So from here, I'm trusting you can finish it up. There's the point. Y minus 4 equals the slope times x minus the x value. Then all you have to do from here is get it looking like this. The trickiest part about all of these is just getting the slope. 25. The graph of f is perpendicular to the line that's given here and has the same y-intercept as this line. So, what's going to be the slope of this line? If you remember, it was that thing I horribly botched earlier. Okay. People are giving me this part, and some people are just giving me what I asked for. The actual slope of this line is -a over b, which is +3/2. +3/2. Now, the perpendicular slope to that would be -2/3. So m for our line is going to be -2/3. Now, it also says we have to plug in the same y-intercept as this. So we really could just jump straight into y equals -2/3 x, but now we just need to know what to plug in for b. Now it stands to reason. I don't remember ever doing this my whole life, which is weird because I've taught this class for years. I'm sure there's a simple little like -a over c or something that you could find the y-intercept. But rather than tell you something wrong for a second time today, let's just solve this for y and see if we can come up with our own little formula. Add 2y, divide by 2, which would just be 2. So I'm guessing, no, it'd be -2, I guess. So looking at our original, I bet the way to find your y-intercept would just be c over b, 4 over 2. Or did I miss a negative sign somewhere? Add the 2y, divide by +2. So -c over b. So there, if you want to put that in your notes, you can. Or you can just solve it for y and pull it out. Yes, sir. So if it wasn't well, you would do your negative, what was it, a over b. And if it wasn't perpendicular, if it was parallel, it would just be that. You wouldn't have flipped it. Because this slope was 3/2. We flipped it and perpendicularized it to get negative 2/3. Yeah, if it was parallel, you would have just used it. Good question. Very good question. Questions about how you're going to do these three? By the way, perpendicularize, I do not believe is a word, so don't go using that. All right, here you go.